Hey, everybody. How are you all today? Everybody doing well? All right. Arhan, good to see you.
Hello again.
What?
Hello again.
Hello again. You're going to get tired of me on Tuesdays.
No.
Aw, thanks. I won't get tired of you either. We have a fun science day on Tuesdays, right?
Yeah.
Yeah. All right. Anybody have any questions? Anything going on that you want to talk about? It's a fun time right now to like share things that are going on in your life. If you've got fun things that you want to talk about, you can do it here. That helps us get to know each other a little bit. All right. Nobody has anything. 4 tests and 3-page paper due this week. That's a lot. Don't fall behind, Valerie. Make sure that you do a little bit every day. Stay caught up. All right. Let me go ahead and share my screen. There we go. Yeah, that is a lot. Okay. Let me know if you cannot see where it says Science Rocks. Because, of course, we're going to be learning about rocks today. So a little play on words there. Science Rocks. That was my password for a long time for some of my things. My password was Science Rocks because it does. All right. I'll start right off, start the day with a couple of jokes. So I just love this one. It's not a joke exactly, but a little saying. I love the way the earth rotates. It really makes my day. Of course, it's the rotation of the earth that gives us day and night. The revolution of the earth is when it goes around the sun. That's what gives us our years. How about this one? What did the earth say to the other planets? The earth say to the other planets? You guys have no life. All right, that's it. Not a lot of jokes today. Oh no, there is one more. There are a couple more here actually. Why are the other layers always jealous of the crust? Because no matter what game they play, the crust always comes out on top. And if the earth was flat, cats would have pushed everything off it by now. And you guys have cats? You know how they knock everything off? Yeah, you can't leave anything on a flat surface or the cat's going to knock it right off. All right. Now, we're going to study rocks today. We learned about minerals last week and then rocks this week. So to understand rocks, we really have to be sure that we understand what those different layers of the earth are. Now, this is a review, but it's important. So we have the outside is the crust. And then as we move down from the crust toward the inner core, the temperature goes up and the pressure goes up. And both of those make sense. Makes sense that there would be more pressure with something that has more things on top of it, pushing down on it, and that the temperature would go up as it goes down. So again, we have to remember that the layers are not, so when we look at these layers like this, it looks like there's just 1, 2, 3, 4, 5 layers. Who's not muted there? I'm gonna make sure I keep all you guys muted. Everybody muted? Yeah, good. Otherwise we hear background noise. So it's not like those layers have a definite line. There's transitions in between them. So you can look at it here. Here's the crust. And then there's the uppermost mantle, and then the middle mantle, and then the bottom mantle, and then the transition mantle, the lower mantle, etc. Now, it might surprise you guys to learn that rocks are constantly being melted and constantly being reformed down inside the earth. So the change, of course, is gradual, and some sources divide it up into all these layers, but for our purposes, for our class, we can use these layers: the crust, the mantle, the outer core, and the inner core. Now take a look at the thickness of those layers. As we work our way down through the layers of the earth, the crust is the thinnest layer. By far, the crust is the thinnest layer. Then we have the mantle, and then we have the core. Now, take a look at this right here, kilometers right here. In English, in America, we use miles. Most of the rest of the world uses kilometers. So think of a mile as being just about 1.6 or a little more than 1.5 kilometers. So whenever you see, oh, I'm sorry, Henry, I didn't see your hand. Go ahead. You're muted. Hit the space bar on your keyboard.
So why would the middle of the earth be the hottest if it's the farthest away from the sun?
That's a really good question. Anybody have any guesses for that? Take a shot. Why do you think? There's a couple reasons. Maisie? Is your hand up? Drake?
There's like magma on the inside of the earth, and because there's no like rain or anything to cool it down, it just gets hotter as there's more and more and it goes farther down.
Okay, that's a really good guess. It's partially right. Yeah. Maisie?
Because longitude and latitude.
You're on the right track. So think about how way back when the earth formed, they think what happened when the earth formed was that very soon after all those the elements came together to make the earth, something from some space, something crashed into the earth, and it hit so hard with so much force that it turned all of the earth to molten. That impact was so great that it caused this extra heat. It melted everything. And so things went, the heavier things went down lower and the lighter things stayed out to the top. Now it also broke off a chunk, which is what scientists think is our moon. There's that chunk that broke off of the earth. But when everything became molten, it was really hot. Well, then, like Drake was saying, that heat's kind of trapped inside and it can't get out. So it is a little bit, we're losing a little bit of heat from the earth over time, but a lot of it is just trapped down inside the earth. Another reason that the inside of the earth is so hot is that there are chemical reactions that are happening down there. What's really happening is that elements are undergoing what's called radioactive decay. So as these big, heavy elements break down into smaller elements, they release a ton of energy in the form of heat. So it's actually new heat being generated way down in the inner core, outer core, and the lower parts of the mantle. So it's a very good question, Henry. Does that explain it? We'll talk more about this later in the course, but that's the nutshell. Okay, so let's start with the crust. This is the outer layer of rock, and it forms what we would call the outer skin of the earth. Now, it also includes the ocean floor and the dry land and all the soil and all the water that covers all the parts of the earth's surface. So all of that, all the land, all the land under the water and the water itself that's on the earth is all part of the crust. The crust that's under the oceans is called oceanic crust. The crust that's under the continents is called continental crust. And it's not the same thickness everywhere. Anybody have any ideas where it would be the thinnest? Where do you think crust on the earth? Again, just take a guess. Maisie.
In the center.
In the center, what do you mean by center?
In the center of the crust.
So the crust is the whole, let me grab my globe here. The crust is the whole coating. So they're really like think of it as being the outside of a globe. That's all the crust. So there really isn't a center. I mean, there's the equator, you know, right there. But where do you think that it's thicker under the continents? Do you think it's thicker under the oceans? Do you think it's thicker under, you know, the valleys or the mountains or, you know, other landforms? It's actually the thickest under mountains, and it's the thinnest under the oceans. So the oceanic crust is thinner than the continental crust. Now, the average thickness of the crust is about 50 kilometers thick, and it has these surface features on it. It has things like mountains and like valleys. Maisie,
What is oceanic crust?
the oceanic crust is just the crust under the oceans. It's the part of the crust that's under the oceans. It has the water on top of it, and it's the thinnest there. Now, you guys, human beings, living things are made up of different kinds of atoms. These are the most common atoms that we find in the human body: hydrogen, carbon, oxygen, nitrogen, calcium, phosphorus. Same thing is true of Earth's crust. It's made up of different kinds of atoms. So take a look at this. Just looking at this, this is called a pie chart. So because it looks like a pie and it's got wedges like pieces of a pie. So what is the most common element in Earth's crust? Makes up almost half of Earth's crust. Drake.
Oxygen.
Oxygen, you got it. You can tell because it's a bigger piece of the pie. So we look here, oxygen. We've also got a key down here. What's the second most common? Maisie.
Silicon.
Yeah, silicon. That's basically sand, is what silicon is. Then there's smaller amounts of a lot of these different kind of elements. But you can see here that a whole lot of the Earth's crust is made up of oxygen and silicon. Now, let's move a little down underneath the crust and we get to the mantle. So the mantle is made up of rock, but it's hot. It is so hot that it's molten. It's about 1,000 degrees Celsius. That's about 1,830 degrees Fahrenheit. Now, once again, in science, we like to use the metric system, but in America, we don't. We use what's called the imperial system. But most of you guys are probably more familiar with the imperial system than you are the metric. So I'm going to use both in our class. I'll go back and forth. It's a good idea to try to learn the metric system. It'll help you when you get to college classes, especially even high school classes. It'll help you. Now, take a look at those temperatures. At those temperatures, the upper part of the mantle is about 1,000 degrees Celsius. Way down near the core, it's 3,700 degrees Celsius. So at those temperatures, rocks melt. What do we call those partially molten rocks? What do we call this that's kind of moving around right underneath the crust? Arhan. Magma. Yeah, we call it magma. So
And
the
when it
mantle,
comes up, it becomes lava.
when it comes out of the earth, it's called lava. It's the same thing. When it's under the surface of the earth, it's called magma. When it's above the surface of the earth or on the surface, it's called lava. Good. So the magma or the mantle starts right here where the crust ends, and it goes all the way down to the core. Now look at what the mantle is made of. Again, it's mostly oxygen and silicon. Interesting, isn't it? Very similar composition. The difference is the temperature. Now, density is also different. Remember, density is one of those properties of objects. So the more dense a substance is, the more matter it has in a given volume. So something like a brick is going to be way more dense than the same size piece of foam, because the brick has way more particles that are packed really tightly together. So that makes it more dense. And denser things are going to sink down below less dense things. So just like in this picture right here, the most dense thing in this picture is honey. Honey is way more dense than corn syrup or dish soap. And vegetable oil is the least dense of all. So it's going to float on the top. Well, the same thing happens in the earth. Denser things sink below. That's why the inner core is the densest place inside the earth. So denser things are found deep in the earth, where lighter things or things that are less dense are found up near the surface. So let's look at the outer core. Look at the temperatures of the outer core. 7,200 degrees Fahrenheit down to 10,800 degrees. I mean, that's hot. That is so hot. The rock isn't even molten anymore. It's straight up liquid. It is liquid rock down in the outer core. Now, the inner core is a little bit different. The inner core is a dense ball of solid metal, but it's even hotter than the outer core. So it's so hot that the outer core is liquid. Why isn't the inner core liquid? If it's even hotter, why do you think it's not liquid? Remember what I told you gets more and more and more as you go in toward the earth? The temperature increases. What else increases as you get to the center? Valet.
Is it because it gets more and more compressed?
Yeah, exactly. Pressure. More compressed. The pressure is so extreme in that inner core that it forces that iron into a solid, in spite of the fact that the temperature is so high. The pressure is just so great. All right, so now we've done a little review of the layers of the earth. Let's talk about rocks. So remember last week we learned about minerals, and we learned that they have these characteristics. They're naturally occurring, they're solid, they're crystalline, and they have a characteristic chemical composition. Now, minerals are the building blocks of rock. So that's why we study minerals first, because now we'll use those minerals to make rocks. So some of the characteristics that define a rock, things that scientists use in order to describe rocks, are minerals that are in it. So different kinds of rock contain different kinds of minerals. We can talk about the roughness or the smoothness of the surface of the rock, whether or not it allows water to pass through, and the size of the crystals that form the rock. When we're talking about rocks, they're formed by various different processes, either on or within the earth. And we divide them into 3 basic categories based on how they form. Anybody remember what those 3 basic categories are? You learned about them yesterday, if you're sticking with the due dates. What are the 3 kinds of rock that we have? Aisha.
There's sedimentary and igneous and I forgot the third.
Okay, you got the first 2. Anybody remember the third? Jasmine? Oh, I can't hear you. Your microphone might not be on. I could read your lips though. You were saying metamorphic. Yeah, I could tell. Yeah, that's what they are. So we have igneous, sedimentary, and metamorphic. So igneous rock, those form when magma or lava cools. Most sedimentary rock is going to form when particles of other rocks or plants get pressed and cemented together. Now they form in layers that are buried often below the surface, and then they're revealed by processes on Earth that bring them up. Metamorphic happens whenever any existing rock, a rock that's already there, is changed. Not melted completely, but changed by heat or pressure or some kind of chemical reaction. Most metamorphic rock forms deep underground. So what I want to do today is talk about the different kinds of rock, and we'll start with sedimentary. So see all this stuff piled at the bottom here? If you guys have ever driven by any kind of a rock mountain, or the way they cut rock away when they're building a road, you've seen these piles of rubble at the bottom. Well, these little pieces of broken rock are called sediment. Now, when that sediment gets pressed together and cemented together, we call it sedimentary rock. So how do you think pieces of sediment get moved from one place to another? What moves them? What moves things around on Earth? Not delivery trucks. In nature. What moves things around? Sophie. Were you raising your hand? Oh, okay, I thought you were raising your hand. Sorry. Aisha.
Wind,
Wind is one.
rain,
Wind and water. Yep, wind and water are the 2. So that's how sediment gets moved around. Now, those are 2 of Earth's processes. They happen on the surface. Wind and water happen on the surface of the earth, and they play a role in making sedimentary rocks. So usually we find sedimentary rocks pretty close to the surface of the earth, and they form in layers, usually over thousands or millions of years. This layer forms, and then thousands of years later, another layer will form. Now, sedimentary rocks also are a little bit soft, and they can break pretty easily compared to the other types of rock because they're just different layers like that. So let's watch this video about sedimentary rock.
The first kind of rock we're going to learn about is sedimentary rock. On top of mountains, it can get pretty windy and rainy. And did you know that this wind and rain can chip away tiny pieces of rocks and dirt away from the mountain? These tiny pieces of rocks and dirt are carried by water down streams to rivers, finally reaching oceans and lakes where they sink down to the bottom. We call these tiny rocks and dirt that sink down to the bottom sediment. Over time, more rocks and dirt sink on top of them, then more sink on top of them, then more on top of them. After a long time,
1 million, zillion, jillion, dillion, cotillion times later,
and things start to get heavy for the rocks and dirt at the very bottom. These layers are squeezed together harder and harder until eventually sedimentary rock is formed.
All right, now, sedimentary rock a lot of times has fossils in it. So remember, they form up on the surface. So they often have the remains of living things inside of them. So a fossil can be either the remains of an organism from the past or the impression that it left behind. So sometimes fossils are like the bones and the shells of something. Sometimes they're just imprints, like footprints that are left in a rock. Fossils are mostly found in sedimentary rock. Think about it, it makes sense. So you've got a layer, and then another layer, and then another layer, and then something dies, and it lays on there, and then another layer is formed on top of that. Well, that thing that died might leave behind some traces, and those traces we call fossils. Now, those fossils form in a couple different ways. A lot of them are the remains of living organisms that died in the water. They become buried in mud before they have time to decay completely. Now, soft parts like muscles and organs, those are going to decompose quickly. But hard parts like shells and bones, those stay behind. Then minerals that are in the mud, remember there's another way that minerals can form. They can form when water evaporates away, leaving just mineral behind. Well, those minerals might move into those hard parts, turning them into rocks. So here's some examples of sedimentary rocks: shale, sandstone, limestone, conglomerate, arkose, and gypsum are examples. Now, not everything that's alive that gets trapped in a sedimentary rock becomes a fossil. Sometimes that living matter that's trapped can form coal. So that's when they're really compressed and heated. And most types of coal that you find are sedimentary rocks that can be burned and used as an energy source. So sedimentary rock is pretty cool. So here's some more fun examples of things you might not have known are sedimentary rock. Did you guys know that sidewalk chalk is a sedimentary rock? So it's a soft form of limestone. It's not very well cemented together, so it's usually powdery and kind of brittle. Anybody have any idea how we get these colors? We don't find those colors in the earth. Pigments are added, just like paint, like dried paint, think of it that way, is added. This is what it looks like in nature. That's what chalk looks like. But they cut it down and polish it so it looks nice and smooth and make sidewalk chalk. Another thing is rock salt, the kind that you might sprinkle on your driveway in in the wintertime to keep the ice from forming. Rock salt is a sedimentary rock. It's formed when seawater evaporates away. Now, keep in mind that rock salt that you use for your driveway isn't the kind of salt that you can eat. It might have some impurities in it. So if you guys have a rock collection, if you got this box of rocks, I told you you can order them together sometimes on Amazon. This is the same company that made the minerals that we had. So if you did order the rock kit, you can take a look at your sedimentary rocks. So I'll show you mine. I have this rock identification key on here, and it'll tell me right there what type of rock it is. So my sedimentary rocks are the ones in the middle. So I have shale, looks like this. Up. And they're going to be pretty soft. If you have them, you can see, you can scratch those with your fingernail pretty easily. The next one that I have is Calcaneus tufa. How's that for the name of a rock? Calcaneus tufa is my next one. And then all the ones that are in the middle of my rock kit are sedimentary rocks. Now, if you got some from outside, you can sometimes tell which ones are sedimentary because they might have layers. They might look like they have those layers in them where the different layers were cemented together. So the next time you're outside walking around, look at the rocks and see if you can find a sedimentary rock outside. Maya wants to stay high. Say hi to everybody.
Aww.
Sometimes she climbs up and wants to have class with us. All right, now let's look at igneous rocks. So this is where magma forms a rock. So when magma or lava cool down, they form igneous rocks. So where do you think you're likely to find igneous rocks? Where on the earth do you think you might find them? Near what? Maisie.
Lava.
Yeah, you're gonna find, but where would you find lava? Isaac.
Volcanoes.
Yeah, a lot of times we'll find igneous rock near volcanoes. Because remember that when hot magma comes up out of the earth, it starts cooling down right away. So when magma flows out of a volcano, it starts to cool down. It can also cool down when it's beneath the surface of the earth as it gets up near the crust area there. So when an igneous rock cools down really fast, those minerals don't have much time to get bigger. So that gives us very small grains. And those grains are often too small to see. If you look at a rock, an igneous rock, you might not be able to see those grains because they're too small. That means that cooled down really fast. If the magma cools down slowly, those mineral crystals are going to be bigger. So you're going to have larger grains in that. So igneous rocks are pretty rich in minerals. They a lot of times have a lot of iron in them. That might make them have a red color to them. So let's watch this guy talk about igneous rocks.
Igneous rock. Igneous rock is formed when rocks become so hot that they melt and turn to liquid. We call them molten rocks. Molten rock that is underground is called magma, and molten rock that comes out of the ground is called lava. When the magma or lava cools down again, it hardens and forms igneous rock. Take a look at my starburst. When I heat them, they begin to melt and form molten rock. Then, when they cool down again, they harden to form igneous rock. Then, once again, over a super long time, this igneous rock is chipped away by the wind and rain. These tiny pieces of rocks and dirt are then once again carried away by the water from streams to rivers to lakes and oceans, where they sink down to the bottom. And the cycle begins all over again.
Yep, pretty interesting. So once again, magma is inside the earth, lava is on top of the earth. Now, there's 3 different kinds of igneous rocks. There's ones that are intrusive, there's ones that are extrusive, and there are ones that are plutonic. And you can see there, it all has to do with the cooling time. Intrusive rocks take thousands of years to cool. Plutonic rocks take millions of years to cool. But look at extrusive, seconds. Sometimes they only take seconds in order to cool down. So the minute that comes up out of the volcano, seconds later, that extrusive rock can harden. Sometimes it can take up to a couple months for that to harden. And here's some examples of igneous rocks. They're really beautiful. They often look pretty shiny. They look a lot like glass. So if you got some rocks from outside, if any of them are really shiny, really glass-like, they might actually be igneous rocks. Even if you don't live somewhere where there's a volcano, they get carried there different ways. So hold on a second here. So in my kit, my igneous rocks, here's an example of some of them. So in my kit, my igneous rocks are the ones that are numbers 1 through 5. And they look, they look like they cooled from lava. There's holes in them. You can see that. There's like holes. They look real porous because as the lava cools, there's air bubbles inside of it. Then finally, we have the third kind of rock, metamorphic. These are rocks that form from a change in another rock. think of the word metamorphosis. You guys probably all know about metamorphosis in like butterflies and frogs, how they go through metamorphosis to change. Well, the same kind of change happens. Sorry here, they're pretty cheap if you go, I don't know what you're talking about there. Hold your comments if you would to questions because I miss things otherwise. So metamorphic rock is rock that has been changed in the same way that metamorphosis changes an animal. So what happens is way down inside the earth, rocks can experience really high pressure and temperature. And because of that, the rocks change. So they tend to be a little bit glassy in appearance and pretty hard. They're very hard. Metamorphic rock is very hard. And it can form out of any kind of rock. You can get metamorphic rocks from igneous rocks, from sedimentary, from other metamorphic rocks. And a lot of times metamorphic rocks have layers. So how can you tell the difference in a metamorphic rock and a sedimentary rock? Well, usually in a metamorphic rock, those layers are not straight. They might be bent, they might be curved like that. And they might have marks on them that show how the rock was stretched and twisted as it was heated. So sometimes they don't have those obvious layers, but sometimes they do. All right, let's watch him talk about metamorphic rock.
And the next type of rock we're going to learn about is metamorphic rock. Sometimes these layers of rocks and dirt deep underground become close to molten hot magma. To add a little bit of heat to this rock, I'm going to use a hairdryer. The heat of the magma combined with the huge pressure of all of the layers of rocks above can cause the rocks at the bottom to be chemically changed into metamorphic rock. But this also takes a super long time. Here's some footage of me climbing on metamorphic rock on a mountaineering course in India.
All right, so here's a couple examples of metamorphic rock. So you can see here, we started with granite, which was an igneous rock. Because of heat and pressure, it became gneiss, which is metamorphic. We started with sandstone, which was sedimentary. Heat and pressure turned it into quartzite, which is a metamorphic rock. Then we started with shale, which is another kind of sedimentary. Heat and pressure turned it into slate. So you guys may have experienced slate before. Sometimes roofs are made out of slate, or you might have a board in your house that's made out of slate. People sometimes will use them for crafts because that you can paint on them really nicely. And here's some other kinds of metamorphic rocks. So marble, you may have a countertop in your house that's made out of marble. If it's really hard and looks like that, it's very beautiful and very strong. Nothing will melt. If you set like a hot pan on a marble countertop, it won't do any damage to that marble because it is so hard. Slate, we talked about. Gneiss, we talked about. A lot of times they'll use gneiss for buildings and pavings, and you can see the crystals right in this rock if you look carefully. And then quartzite is often used for countertops too, because it's really hard. Again, metamorphic rocks are really, really hard. Marbles are made out of glass, yeah. Usually the marbles that you play with they're called marbles, but they're made out of either glass or a kind of a hard, very hard plastic, but usually glass.
Yeah.
All right, so take a look at the questions here now. Tell me what the 4 main layers of the earth are. What's the outermost layer? Aisha.
Crust.
Crust. What's right under the crust? Mantle. You got it, Kaylin. What's right under the mantle? Aisha.
The outer core.
The outer core. And then under the outer core? Yeah, is the inner core. Very good. There they are. All right. What determines how rocks are divided into one of 3 general types? Remember, we can put them into 3 categories: metamorphic, sedimentary, igneous. What makes the difference? Simple answer, how they form. How they form. So remember, igneous rocks form when magma cools. Sedimentary rocks form when tiny rock particles are pressed together. And then metamorphic rocks form from other rocks that get under extreme heat and temperature inside the earth. How they form is what makes those 3 different kinds of rocks. So let's look at a couple different kinds of rocks and you tell me if you know which kind they are. What do you think that is? Sophie. Didn't hear you, Sophie. You're muted. You still trying, Sophie? Oh, your sound isn't working. Okay, so I'm seeing a lot of metamorphic, but these lines are pretty straight. When you see real straight lines like that, that usually means sedimentary. Yeah, the twisted lines are going to be metamorphic. All right, how about this one? What do you think this is? Very shiny and glassy. This was formed from magma. Aisha.
Igneous.
Igneous. Yeah, very good. Which kind of rock are most likely to contain a fossil? Maisie.
Let's see. Metamorphic.
Not metamorphic. Remember, they get trapped in the layers. See, I see a lot of sedimentary being written there. Sedimentary rock has the layers, and the fossils, the animals or plants get trapped in the layers and they become a fossil inside those layers. So what are we looking at here? What kind of rock is this? Flat layers, flat layers. Yeah, this is going to be sedimentary. Now, metamorphic can have layers too, but usually the metamorphic layers are not straight flat like that. Think about how they form. So the way that this sedimentary rock forms is that the sediment is deposited and then it's cemented down over time as things pile up on top of it. So makes sense that it would be flat layers because things are generally going to be deposited in a flat layer like that. Okay, fill in the blank of this one. Minerals are the building blocks of what? Aisha.
Rocks.
Rocks. Minerals are the building blocks of rocks. All right, so this kind of rock was formed when other kinds of rocks melted below the surface or got real hot and under a lot of pressure below the surface. What kind of rock is this? Metamorphic. This is metamorphic rock. So look at how these are, the layers are real like twisty and distorted. They're not nice flat layers like that. All right, how about this one? Metamorphic rock can change into what kinds of rock? Maisie.
Sedimentary rocks.
Sedimentary. What else? Yeah, Valley's got it. Any. Really, we'll learn next week when we study what's called the rock cycle. Any kind of rock can be converted or transformed into any other kind of rock. All right, so take a look at this question here. Which is not a type of rock? Aisha.
Mineral.
Mineral. Minerals are not rocks. Rocks are made out of minerals, but minerals are not a type of rock. The three types of rock are sedimentary, igneous, and metamorphic. Okay, look at this. You find a rock that feels soft, rough, and grainy, and it has a layered appearance. Which type of rock is it? That soft gives it away. Yeah, I'm seeing some sedimentary there. Yeah, sedimentary rocks are soft. A lot of times you can just flip, like you saw him in the video taking his finger and scraping off that particles of rock. That's probably sedimentary if it formed in that way. All right, anybody have questions about type of rocks? All right, we're going to do a Kahoot. Are you ready? Now I have two different Kahoots. Let me see which one we're going to do. All right, let me take a vote. You guys want to do one about rocks, or you want to do a review of the first 4 chapters? So if you want to do rocks, put your hand up. There we go. 1, 2, 3, 4, 5, 6, 7. All right, if you want to do the review, put your hand up. 1, 2, All right, rocks wins. We may have time to do both. Let's see. There's not a lot of questions in either one. So let me get this started. Here we go. You go to www.kahoot.it, kahoot.it. Here we go. Right here, www.kahoot.it. You can use the app or you can scan this code. It'll take you right to the game without having to put in the pin. Game pin is 878142. 878142. All right, here everybody comes. 878142.
Wait, what? 878142?
Yes.
But my Kahoot isn't loading. What am I supposed to type in again?
www.kahoot.it.
You also can just type in Kahoot and it'll bring it to you automatically.
Will it? Okay.
87.
The password is, or the game pin is, I will type it in the chat box for you so you guys can all see it.
What I do?
878142. 878142. Okay.
What I do is I made a little tab for it so that I can just click on it and open Kahoot.
Yeah, that works too. Save it as a bookmark. All right, we're going to get started. If you haven't joined yet, you can always join with this game pin. It'll be down here at the bottom always. All right, here we go. There are 12 questions in this Kahoot. Rocks, rocks, and more rocks. What type of rock is formed from cooling lava? Very good. Igneous rock. Igneous rock is formed from cooling lava. All right. The bomb starts with Drake not far behind. Ooh, and I like math is tied with Drake. Here's our next question. Small pieces of broken rock are called? They're called sediment. Remember, sediment is what forms sedimentary rock. Those tiny pieces of broken rock are blown by wind or carried by water, where they are deposited and then cemented together to form that sedimentary rock. I like math takes the lead. Henry VIII is in second place. Which type of rock may contain fossils? Sedimentary. Very good. Excellent, everyone. Question 4. How are metamorphic rocks formed? Heat and pressure. Heat and pressure. All right. What type of rock may contain tiny holes from air bubbles? Igneous rock. Igneous rock. Very good. All right, let's see here. Valley moves into the lead. Meredith is in second. What type of rock is formed from the compacting of sediment? Pressure together. Put those nice flat layers. That is sedimentary rock, not metamorphic. Remember, metamorphic happens when heat and pressure changes the shape and maybe even the composition of the rock. When they're just compacted sediment, that's sedimentary rock. All right, Henry VIII moves into third place. When rock is heated and molten, it becomes... When rock is heated and becomes molten, we call it magma, when it becomes completely molten. All right. Henry VIII moves into second place. Metamorphic rock may contain what do you think? Metamorphic rock may contain what? Try to answer quickly. May contain crystals. So metamorphic is not going to contain fossils. Remember, metamorphic means that it got under such heat and pressure, even the fossils would have been destroyed. Even like bones or pieces of shell would have been destroyed. So it isn't lava. Lava is what magma is called when it comes out of the earth. And bugs, of course, is not an answer. So crystals. Sometimes you can even see the crystals in metamorphic rock. All right. Question 9. What type of rock may look shiny and glass-like? Obsidian is a good example of this kind of rock. It's the most shiny of all the kinds. That would be igneous. So sometimes metamorphic rock can have a little bit of a shine to it, but it's not nearly as shiny and glassy as igneous rock is. Question 10. What's your favorite type of rock? No right or wrong answer here. Igneous rock. All right. So those were all correct. You got points for all of those. All rocks stay the same forever, are constantly changing, can only change once, or are formed the same way. They are all constantly changing. Excellent. So all the processes on Earth, the water, the wind, the ice, they're all constantly changing. And as they go below the surface, they change again. All right. Valet, I Like Math, and Henry VIII. Here's our final question. Where do you think this rock was found? Take a look what's in the rock. Where do you think it was found? In the ocean. Yeah, there were some shells in there. So that would have been found in the ocean. All right, let's see our podium here now. In third place, Meredith. Well done. In second place, I Like Math. In first place. All right, Valet. Very good. Arhan, are you I Like Math? Yeah, I saw you do the handshake. All right, let's do another one then. Let's go ahead and do our review. This is just a review of the kind of things that you've done so far in class this year. Let me close this one. Leave. Once again, www.kahoot.it.
What's the game pin?
It's coming up now. I'll type it in. It is 502-1275. 502-1275. (502-1275). Interesting names you guys are picking today. All right, here we go. A possible explanation for a set of observations is called what? Possible explanation for a set of observations. That's called a hypothesis. Well done. Well done. We're going back a couple weeks now. You guys know we finished 4 weeks already. That means we are 1/4 of the way through this semester. There are 18 weeks or 16 weeks in the semester, and we've got 1/4 of them done already. It's going fast. Question 2. A test of a hypothesis that tests only one variable is called One variable. That's called a controlled experiment. Very good. Controlled experiment. Question 3. A factor that can change in an experiment is called a variable. Very good. A variable. The ability to do work or cause change is called what? It's called energy. Energy. That's what the definition of energy is. The ability to do work or cause change. All right. Immigrant Song takes the lead. Double points for this one. Who is responsible for lab safety? Everyone. Everyone is responsible for lab safety. Yep. I'm going to go fast so that we can get as far as we can. In the lab, safety goggles must be worn when working with heat chemicals or glass, can be removed to quickly clear them if foggy, can be substituted with eyeglasses, or can be worn on your forehead if you aren't touching anything. Yeah, you gotta leave them on. Always gotta leave your safety goggles on. Protect those eyes. You only have one set. All right, name this science safety tool. What are these called? You have too long on that one. Beaker. Those are called beakers. All right. All of the following are examples of landforms, except icicles, right? They are not landforms. The prime meridian is a line of longitude or latitude. What the prime meridian is? It is a line of longitude. So remember, longitude are the long ones that hang down. Think long hair dude. They're the ones that go this way. And the prime meridian's right about there. Yeah, well, right about here, actually. Yep. All right, next question. The equator is a line of, if the prime meridian was longitude, then the equator is latitude. Exactly. Exactly. Which of these properties cannot be used to identify a mineral? Luster, hardness, streak, or mass? Think about the things that we tested last week. Which one did we not test? Mass, right? We don't use mass to identify minerals. Multi-select, pick more than one. Which of the following are characteristics of a mineral? Pick all that apply. Liquid is not, oh, it says, guys, liquid is the, it shouldn't be. It shouldn't be one. So whoever got that one gets a free point. But yes, inorganic, naturally occurring crystalline structure, it is not a liquid, it is a solid. So I'm sorry I messed up on that one, but oh well, just one person was affected. Which statement is true? Minerals are made of rocks. Nope, I got that one wrong too. Yikes. Yeah, I'm sorry. I made this really quickly before class, so I messed that one up. But oh well, everybody got that one wrong, so it didn't change anything. Rocks are made of minerals, you're right. All right, the term that describes the way a mineral splits along flat surfaces. One of those terms is when it splits flat, when it makes a nice flat line. That is called cleavage. Cleavage. And The term that describes the way a mineral breaks in an irregular way, not flat. That is called fracture. Well done, everybody. All right, we'll do one more. A solid mixture of two or more elements when at least one is a metal is called what? It's called an alloy. All right, you
I
guys
think
are
you've
doing
had
quick.
definition.
Maybe we can keep going. A rock that forms from the cooling of magma or lava is fast, fast. Igneous. A rock that forms when particles of other rocks are pressed or cemented together. Sedimentary. And the last one, we did it. A rock that forms when an existing rock is changed by heat, pressure, or chemical reactions is metamorphic. Excellent. All right, let's see how we did here. In third place, is that Iozer or loser? Arhan is in second, and in first place, who is? I have no idea. The bomb. The bomb. All right, that was great. You guys did really well. You remembered a lot, so very well done. I'm proud of all of you. All right, keep up the good work, everybody. Keep working, and I will see you next week. Bye.
Fine.